So good evening. I'm going to try to explain to you one more time the inverses because some of you are still confused. And I understand sometimes this might be tedious at first, right? It's not easy. So what we need to understand is we need to find a inverse. And the first question that we need to ask ourselves is, does the inverse exist or not, right? How can we find out? How can we know? Well, you take the determinant. If you take the determinant and the determinant equals to 0, then the inverse does not exist. If the determinant is any number, any other number that is not 0, then the determinant exists, right? So how can we do this? Okay, first of all, we need to compute this, right? We can use Sarro's method. And if we use Sarro's method, we get 1, 2, 2, then 1, 0, 1, right? Let me put that a little nicer, 1, 0, 1. And then we compute this, right? So this is this way, this, and this, right? So let's compute, and that's the major diagonal, right? So if we do that, we get 0 plus 4 plus 4, right? Minus the minor diagonal. So the minor diagonal is this part right here. Minor diagonal is this part right here. This one, and this one. Let's compute that. So that's 0 plus 2 plus 2. So this is 8 minus 4. Let me double check. So it was 0, 4, and oh, this is 2, by the way. And then we have 0, 2, and 2. Now it's okay. So this is 6, and this is 2, right? So the determinant is 2. That means the inverse exists. So let's compute the inverse now. Okay, so what's the inverse of this? Okay, now that we know that the inverse exists, let's find it, what it is. So again, the main idea is you are here in this matrix block and you need to go here. This is the main idea, right? This is your goal. You are here, right? And you want to be here. Okay? That's the main idea. So this is your goal, right? Like I always say, that's your goal. So now let's erase this and let's augment it. So now you have 1, 0, 0, 0, 1, 0, 0, 0, 1, right? Just now this one is this one, right? The matrix A is on the left side and the identity is on the right side. But we need to reverse that, right? We need to get the identity on the left side and we need to get the inverse on the right side. So let's do Gaussian elimination, right? Okay, so this is negative row 1 plus row 2 will give you new row 2. Remember, we're trying to get zeros here and here, right? Just keep that in mind all the time. We want to get zeros here and here. That's my goal. Okay, and then I need to do negative row 1 plus row 3 will give me new row 3. So let's compute this. So we need to get rid of that one, right? So first, let's work with row 2, right? Step by step. So negative 1, remember, we're multiplying negative 1 times row 1. Negative 1 times all the elements in row 1 plus row 2. So negative 1 times 1 is negative 1 plus 1 is 0. Negative 1 times 2 is negative 2. Negative 2 and 0 is negative 2. Negative 1 times 2 is negative 2, and 1 is negative 1. Negative 1 times 1 is negative 1, and 0 gives you negative 1. Negative 1 times 0 is 0, and 1 is 1. Negative 1 times 0 is 0, and 0 is just 0. Now we need to get rid of this guy, row 3, right? So you multiply negative 1 times all the elements in row 1 plus row 3. So negative 1 times 1 is 1. negative 1 times 1 is negative 1, and negative 1 and 1 gives you 0. Negative 1 times 2 is negative 2. Negative 2 plus 2 is 0. Negative 1 times 2 is negative 2, and 1 gives you negative 1. Negative 1 times 1 is negative 1, and 0 gives you negative 1. Negative 1 times 0 is 0, plus 0 is 0. Negative 1 times 0 is 0, and 1 is just 1. Now you can divide row 3 or multiply row 3 by negative 1. So negative 1 row 3 gives you new row 3. So let's get rid of all these negatives, right? So this is going to be positive now. This is going to be positive now, and this is going to be negative now, right? That's all I have to do. Now, next step. Next step will be now that I have, you see, I accomplished my target, right? My target was just get rid of those numbers, and I did. And I have a 0 here too, so I don't need to do a computation for that position 832. I don't need to do that no more. So what's next? What's next is we need to get rid of, because now this is in row echelon form. So now we need to go to reduce echelon form to get rid of these numbers, right? This, and this. And the first thing I should do is get rid of these two guys first, right? These two. Okay, so how can I do that? Very easy. Let me move this a little bit. You can multiply, or you can just basically add, right? Row 3 plus row 2 will give you new row 2. And we can accomplish that. And then we can do negative 2, row 3 plus row 2 will give me, I'm sorry, not row 2, row 1, will give me new row 1. Okay, so if we do that, so we can get rid of what? Let's start with row 2. So row 3 plus row 2 gives you 0. Row 3 plus negative 2, sorry, basically we add in row 3 plus row 2. So 0 plus 0 is 0. 0 and negative 2 gives you negative 2. 1 and negative 1 gives you 0. 1 and negative 1 gives you 0. 1 and 1 gives you 1. Negative 1 and 0 gives you negative 1. So accomplish that, right? Now, we can leave that division at the end for row 2. Let's continue with row 1 to finish it. Oh, I need to do that too, right? So I need to get rid of that too. So yeah, so row 1 is gonna disappear, right? Row 1 is gonna disappear. And if you do the computation, it's negative 2 row 3 plus row 1. So negative 2 times 0 is 0 plus 1 is 1. Negative 2 times 0 is 0 plus 2 is 2. Negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 1 is negative 2, and 1 gives you negative 1. Negative 2 and 0 is 0 plus 0 is 0. Negative 2 times negative 1 is 2, and 0 is 2. Right? So now I can get rid of that this guy, right? I'm just gonna add it, right? I'm just gonna add row 2 with row 1, and I can solve that. So basically we're doing row 2 plus row 1 gives me new row 1. Let's compute that. So that would be what? So we're getting rid of this guy, row 1, that's gonna change. So 0 and 1 gives you 1, negative 2 and 2 gives you 0, 0 and 0 gives you 0, 0 and negative 1 gives you negative 1, 1 and 0 gives you 1, 1 and negative 1 and 2 gives you a positive 1. So the only thing left to do is divide or multiply by negative 1/2 row 2, and that will give you new row 2. And we're done after that, right? We're done. So I need to divide everything by 1/2. So if you do that, negative 1/2 times 0 is 0, negative 1/2 times negative 2 is 1, negative 1/2 times 0 is 0, negative 1/2 times 0 is 0, negative 1/2 times 1 is negative 1/2, and negative 1/2 times negative 1 is positive 1/2. So this is the inverse, right? So this is A, and this is inverse. I'm sorry, the other way around. This is identity, and this is inverse, right? And that was the goal. Remember, we come from A, this is the block matrix, A augmented with the identity becomes identity augmented A inverse, and that's our goal, right? That was the goal, this one right here, and we accomplished that. Now you might say, Mr. Flores, how do I know I'm right if I don't have the answer key? Well, you need to multiply, right? You will need to do that long way, right? So remember, this is A inverse now. So let's find out, let's do the matrix multiplication. If I do A times A inverse, I should get the identity, right? So let's do that. Let me change this. That's what I have so far, right? Okay, so now let's multiply by A. What is A? This guy. So let's multiply. Okay, make this a little bigger. Okay, let's multiply that. We have to use matrix multiplication. And when you're using matrix multiplication, you're using basically the dot product, right? The dot product. Okay, let's do that. Before you do the dot product or any matrix multiplication, you have to see the dimensions they match, right? So this is m by n, and this is m by n. You have a 3 by 3 here. You have 3 rows. M is what? The rows, and n is columns. Okay, so you have to keep that in mind. Now, you need to multiply row by column, right? And I was talking about dimensions and I forgot. So this is 3 by 3. So if this n and this m, they match, then you can do the matrix multiplication, right? And you will get a 3 by 3 matrix. These two, n and m, must be the same. If they're not the same, I'm talking about these two. If they're not the same, this will not work. And as a result, you will have just, well, if these two are the same, m and n and m are equal, then you will get a 3 by 3, right? As I just show you, right? So now you need to do the dot product. Let's do the dot product, row by column. So this is 1 times negative 1, 2 times 0, plus 2, right? So that should give you 1. So this is negative 1, 0, and 2. That gives you 1. So indeed, that's 1. Next, let's keep this here for now. Maybe you're still watching or whatever. Okay, so now we need to do row 1, column 2, right? Because we do row by column, right? So what's next? We should get 0 this time. So this is 1 times 1 plus 2 times negative 1/2 plus 2 times 0. So this is 0 goes away. This is 1 and this is negative 1. So negative 1 and negative 1 gives you 0. So that's what you have, right? So far we're getting the identity. So that's good. Let's erase this. Now let's do row 1 and column 3. So 1 times 1, 1, plus 2 times 1/2, and then plus 2 times minus 1. I should get 0 here. So this is 1, 1, minus 2. 1 plus 1 is 2, minus 2 is 0. Right? You can do that. So what's next? Now I finish with row 1. Now I have to do row 2, column 1. Dot product, right? Dot product. So this is what? Negative 1 or 1 times 1. Let's do step by step. 1 times negative 1 plus 0 times 0 plus 1 times 1. So I should get 0 here. Negative 1 plus 0 plus 1. So this cancels out. So this is 0. Next. We need to do what? Row 2, column 2. We should get a 1 there. So this is 1 times 1 plus 0 times negative 1/2 plus 1 times 0. So this is 0, 0, and you get a 1. And that's what's happening, right? So that's good. So we did the computation right. So now we need to do what? Row 2 and column 3. Compute 1, 0 times 1/2 plus 1 times -1. Right? Now we should get a 0. So it's 1, 0, -1, 0. Yes? So that's good. And then let's do, now that we're done with row 2, we have to do row 3. Okay? Row 3, column 1. We should get a 0 here. 1, 81 plus 2 times 0 plus 1 times 1. 81 plus 0 plus 1. 0. Yes? That makes sense. So next, we have to do row 3, column 2. So this is 1 times 1 plus 2 times -1/2 plus 1 times 0. We should get what? We should get a 0 here. So this is 1 minus 1 plus 0. So this cancels. So this is 0. And the last one, it should be what? Row 3, column 3, right? And if we do that, we should get a 1. 1 times 1 plus 2 times 1/2. This is the dot product, by the way. Plus 1 times -1. So this is 1 plus 1 plus -1. So this is, well, we can cancel this too, right? So this negative cancels, and this is 1. So we got our answer, the identity. And that means that A inverse is this guy right here. This is A inverse. Okay? So I'm gonna stop here because I don't want to make the video 3 hours or too long. I'm gonna try to make it more shorter. I hope you understand. If you still don't understand, just send me an email and tell me, Christopher, I don't get it. And then I will try to help you. Recording myself more, or I don't know, we can do a Zoom, you and me, and I can help you individually, right? If you're still struggling. But let's review before we leave. The main idea is, before I find the inverse, I need to find out if it exists or not, right? If it exists, then we can use Gaussian elimination to find it, right? As I did here, this is the goal, right? The goal is going from this block matrix to here. That's my goal, right? This is the goal. This is the main idea of doing all this computation, this thing right here. This is the goal, right? And we need to do all these row operations. Basically, we're doing the Gaussian elimination algorithm to find out if what's the inverse. Once we achieve the inverse, we can check our work multiplying A times the inverse, which should give you the identity. If that's the case, then you compute it right, and the A inverse is what you have. If not, if you multiply these two, that matrix A times its inverse, and doesn't give you the identity, then you know you did something wrong. Don't forget, when we're doing matrix multiplication, basically we're using the dot product. What else you need to remember? Remember, every time when you're doing matrix multiplication, the dimensions, they have to match. If the dimensions, they don't match, then you cannot do matrix multiplication. In this case, we have a square matrix, right? We have a square matrix because this is a 3 by 3, right? How do I know it's a square matrix? Because the number of rows and the number of columns are identical, or they're exactly the same. That's how you know it's a square matrix. Now, I will let you go, and I hope you have a good night. And if you're still confused with this, just let me know, send me an email, and I'll try to help you. Have a good night. Bye.